Me and my groupmates have been assigned to do the topic quarks. We have done few readings and information discovering about this topic. Before we get deep into this topic, let us introduce ourselves. Starting by me, my name is Inshira binti Abdullah and my matrix number is 202921.
Assalamualaikum and hi, my name is Isma Uzair bin Muhammad Zamri. My matric number is 200600.
Hi, my name is Azima binti Azmi and my matrix number is 200855. I'm a student from Department of Physics, University Putra, Malaysia. The topic that we are going to talk about today is quarks. So the objective of this video is first to study about the definition of quarks and the brief history behind it, to understand about different types of quarks and the mechanism involved, to explain about colors of quarks involving the charge and force. So, before we go deeper, let me introduce what is quarks. Quarks is a type of elementary subatomic particles that interact by means of the strong force and are believed to be among the fundamental constituents of matter. In simpler words, all observable matter is composed of quarks. Quarks associate with one another via strong force to make up protons and neutrons, which latter particles combine in various proportions to make up atomic nuclei. Quarks have various intrinsic properties including electric charge, mass, color charge, and spin. So, who's the genius behind all this discovery? In 1961, two physicists, Murray Gell-Mann of the United States and Yuval Ne'eman of Israel, proposed a particle classification scheme called the eightfold way, based on the mathematical symmetry group SU3, interacting particles in terms of building blocks. In 1964, Gell-Mann introduced the concept of quarks as a physical basis of the scheme. Gell-Mann's model provided a simple picture in which all mesons are shown as consisting of a quark and an antiquark, and all baryons as composed of 3 quarks. So, that is the briefing of the history and also a short introduction. So my friend Isma and Inshira will go deeper and explain about the mechanism, the types, and the color of quarks.
So I will talk about type of quark. In 1964, Murray Gell-Mann and George Zipf suggested that most of the known particles could be explained as being combinations of 3 fundamental particles. Now, the term fundamental means that the particle does not have a substructure, so therefore it cannot be split. In general chemistry, William Howe J.J. Thomson cathode ray experiment proved about the realization that atoms were not the smallest things, and soon realized that atoms made of protons, neutrons, and electrons. But as turned out, protons and neutrons are in turn made up of smaller particles, and these are quarks in different varieties. The name quark was given from a quote from James Joyce's novel called Finnegan's Wake. 3 quarks for Master Mark. The first quark theory included 3 type flavors, which are up, down, and strange. In order for their calculation to work, however, these quarks needed to have a fractional charge. The up quarks, which has a charge of positive 2/3 of the charge of an electron, while the down and strange quark have a charge of negative 1/3. The discovery of the up, down, and strange quarks was followed by the coming years by charm, top, and bottom quark. Up and down based on component on their spins. Strange quarks were given the name strange because they were observed in particle decays that had slightly longer lifetime than they should have done. The charm quark were discovered by experimenters at Stanford and Brookhaven National Laboratory with a mass of 31,000 megaelectronvolts, over 3 times that of the proton. The name given due to its fascination as the way it fascinated the physicists at the time. Bottom and top quarks were chosen by a famous physicist called Harari, where he chooses that name because they were the logical counterpart of the up and down quarks. Each of them differ in masses and property of spins. Up and down quarks have the lowest masses of all quarks. The heaviest quarks rapidly change into up and down quarks through a process of particle decay, which is the transformation from a higher mass state to a lower mass state. Because of this, up and down quarks are generally stable and the most common in the universe, whereas strange, charm, bottom, and top quarks can only be produced in high-energy collision, such as those involving cosmic rays and in particle accelerators. For every quark's flavors, there is a corresponding type of antiparticle, known as antiquark, that differ from the quark only in the sum of its properties, such as the electric charge, have an equal magnitude but opposite sign and denoted with a bar at the top of its head. Now, I will show you the three examples of proton, neutron, and antiproton. So the proton was found to be made up of 2 up quarks and 1 down quark. Now, we know that the charge of a proton is positive 1. If we were taking this in terms of fractional charge given to quark, 1 up quark will have a charge of positive 2/3. So therefore, 2 up quark will have an overall charge of positive 4/3. Adding a down quark reduces the overall charge to 3/3, which is the equivalent of 1. Neutron have an overcharge of 0 because it made up from 2 down quark and 1 up quark. Meanwhile, antiproton was consist of same property as protons but in opposite magnitude of charge.
Thank you, Isma, for your explanation on the types of quarks. So now let me tell you about the color of quarks. You're probably thinking about what is actually the color of quarks. Color is actually the strong interaction analog to charge in the electromagnetic force. The term color was introduced to label the property of quark, which allowed some type of quarks to be placed in the same particle. For example, 2 up quarks in the proton. A property of 3 values is needed to allow 3 particles to reside in some proton. To solve this, quarks comes in 3 varieties which are usually red, blue, and green. The Pauli exclusion principle applies separately to each color. For example, a baryon will always have 1 red, 1 blue, and 1 green quark. This of course has nothing to do with real color, but it actually provides 3 distinct quantum states. Each gluon has a color and anticolor, for example blue with anti-red, that allows it to transmit color when exchanged, and color is conserved during transmission and absorption of gluon by a quark. The gluon exchange process changes the colors of the quark in such a way that there is always 1 quark of each color in every baryon. Similar process occurs in light mesons such as pion. The quark-antiquark pair of mesons have cancelling colors such as blue and anti-blue. Thus, mesons do not have net color. This shows that labeling quarks in colors are very important to the quarks model. This is because the color of quarks is actually the force between the quarks. The strong interaction between the quarks in baryon are colorless, as we have learned previously. But the 3 primary colors that made up the strong interaction between the quarks. So what have we learned from this video? In the end, we have learned about the definition of quarks and the brief history behind it. Next, we have understood about different types of quarks and its mechanism. And lastly, we have learned about the color of quarks. We hope you enjoyed our video. Thank you very much.